Alright. Now actually in this section we are going to study about the stack and the heaps. Basically we have just seen that the class members, actually if we can just study here, stack and heap both are actually the part of memory, but we need to keenly understand. In fact, all the programming languages since they evolved, they have been using stack and heap. They have been using the stack and heap. Now basically we have RAM, we have this RAM. Now when the program starts executing, what these programs will actually occupy a space inside the RAM. Now there is a small the RAM has been divided into basically it is having 3 to 4 parts, but currently I'll discuss only about 2 parts. One part is stack and other part is heap. Right. Now heap is a very important part as far as we are concerned, or as far as Java is concerned. Now stack is only a small portion while heap occupies a large portion. It's like that. When actually a program starts executing, if you can just see now stack and heap. First we can just discuss the difference between stack and heap. Right. So a stack memory actually stack is faster memory. It is a faster memory. Now so we can use it since this is a faster memory, but it is present in less amount. It is not present in large amount. It's present in small amount. Moreover, the point is that the stack occupies, or stack stores variable for small amount of time. Stack will store variable for small amount of time. It will store variable for small amount of time. Well, when we talk about the heap section, right? So heap, what is heap? Heap is a larger memory. Heap is a very large memory, right? Okay, and it occupies data, but as compared to stack, it is a slower memory. As compared to stack, it's a slower memory. It occupies huge amount of data. And it occupies the variables or data for larger amount of time. It occupies data for larger amount of time. Right. Now actually what happens, there is one more very important point, that each and every program has its own private stack. It's like when you begin with something, when you go to a class, you have your own notebook, right? So that notebook is like a stack in which you will be writing your personal notes, but the board on which everything is written is like a heap, where all the students of the same class will be referring to the same board. Right. So when the program starts, a small amount of memory is allotted to the program, and this small memory is stack memory. So when the program starts, a small amount of memory is allotted personally to the program. Right. This memory is like the personal register of the program. Right. What does a program does of this stack memory? So program uses its personal memory for, first and foremost thing. Actually, I'll just write down here in briefly, and then I'll explain it in detail. First, it will store, allocate and deallocate the private or the local members. the local members occupy memory inside the stack. And second thing is that all the method calls will be stored here. They will be stored here. While heap is a memory that is shared by all the programs, right? Heap memory is shared by all the programs. All the programs are going to share it. Now basically, if we just talk about, I'll just explain these 2 points here. Now, if suppose I have a small program here, the program is as class test, and we have is int x equal to 10, int y equal to 20, right? And void sum, let's say, okay, void sum, and it has int z equal to 30, right? And then you write for public static void main, right? We have this, right? I'll just put it into small font so that we can see it in a complete page. Now basically when the program starts executing, right? So what is going to happen here, this specific inside this is, let's say, the heap memory, and when the program will start, a personal stack will be initialized, right? Heap is common here, right? So this is stack memory, so this is personal stack of program, this is personal stack of program, while this is the heap memory of the program, this is the heap memory of the program, or this is the common heap memory where all of them are going to occupy the same space, right? Now the class members will occupy memory inside the heap. When an object is formed, test t1 is equal to new test. Now if you see here, one important thing, that inside the object, x is present, y is present, x is present, x is present, y is present, we also have sum. We have x, we have y, and we have a sum here. Now basically z will not occupy a memory here. In fact, actually method name is written here. Method will not occupy memory here. Or maybe, see, method, fine, the method body will be present here. Method body will be present here. But only when a method is called, it occupies memory. Else it will not occupy any memory. So when suppose you are going to call t1.sum, so it is simply going to call this method. It is going to call this method, right? Now basically when it is going to call this method, first and foremost thing, as I already told you, it will write the method calls. So it will write that sum has been called. t1.sum is called. It will store the method call. As I have already told you that it does it for two basic things. All the method calls will be stored here. So simply the method call name, which method has been called. And second, when a method is executing, only at that time its members will occupy memory, else they will not occupy memory. Means if I just call sum, so this sum will start executing, and the variables inside this sum will occupy memory. So here z is going to occupy memory. Z will occupy a memory here, right? So z will occupy, z equal to, let's say, 30. And when the method call is over, means your job is done. As the method call is over, all the data of the method is deleted, right? As the method call is over, this complete stack will be refreshed again, and z will be deleted, as well as t1.sum will be deleted. A method will only occupy memory when it is called. right? So a method only occupies memory. A method will only occupy memory when it's called. When it's called, at that time it occupies memory, and it the local variables will occupy memory inside the heap. They will occupy memory inside the heap. Once they occupy memory inside the heap, once they are occupying the memory inside the heap, right? As soon as the method call is over, that memory will be deleted again. So as soon as the method call is over, that memory will be deleted. So hence the local members occupy memory inside the stack, and there is also a reason for it why it is done, right? Local members will occupy memory in the stack because stack is a faster memory, and inside a program we may need to call the methods many times. So it will result into frequent time of memory allocation and deallocation. Frequent memory allocation and deallocation, that is, many times the memory will be allocated and many times the memory will be deallocated. So due to this reason, since stack is a faster memory, it will improve the performance of the program, right? So methods may be called many times in the program, so the memory will be allocated and deallocated multiple times. Now, since stack is a faster memory, thus it will increase the performance of the program, and hence it is going to increase the performance of the program. So it works in the following manner, right? Now basically we can also see one thing, that inside a program the instance members, suppose it's int x equal to 10, int y equal to 20, or I will not initialize anything in it, int x and int y, and I'll go for string s also. I'll just keep it like this, right? Now public static void main string s. Now basically when an object is formed, they will occupy memory, right? If we do not provide any value to them, they will not take garbage value as in C language. Instead they will automatically take a default value, right? So suppose I make test t is equal to new test, they will take a default value. Default value is integer will automatically take a value of 0 and string will automatically take a value of null, right? So here if you just see system dot out dot println t dot x, so we have it, and we will go for system dot out dot println t dot s, right? If you just see, let's run it here, so it's 0 and null. So the class members, if they are not given any value, okay, class members automatically get a default value when they occupy memory, that is when the object is formed, So automatically occupy default memory. For example, integer will occupy a memory of 0, float will 0.0, then boolean with a false, character with the empty space, and similarly string with a null. These are the default values. Well, local members, if they are not initialized, we cannot leave it like them. Just see, for example, I will just make a local member as int t, and I just keep it like this. Now system dot out dot println and may go for t. Right, now it gives you an error. What is the error? The variable t might not have been initialized. The variable t might not have been initialized. Now basically the point is that if the local members cannot be left uninitialized, you should initialize them, right? But instance members, if they are left uninitialized, they will be automatically initialized, but local members will not be automatically initialized. In fact, if you try to print a uninitialized local member, it gives you an error. The variable might not have been initialized, right? So you can just conclude this point that but local members cannot be left uninitialized. If we leave them uninitialized, we get a compile time error. Variable might not have been initialized. The variable might not have been initialized. That this specific variable might not have been initialized. We should also be able to differentiate between the instance members and local members, as well as the difference between stack and heap, as well as the difference between the stack and the heap. We should be able to know the difference between all of them, right?